Hello there, everybody. I hope you guys are doing well. We are going to use Ohm's law to find the current that is going through one element of this circuit, and this element is the resistor here, and we are going to find the current that is going through the 5 ohm resistor. And then we will use our knowledge to find the power dissipated in this resistor here, the 15 ohm. Okay, so how do we go about solving this problem? Every circuit is actually different when it comes to applications of Ohm's law. You have to look at the circuit very well and see where you can start solving this problem. In my opinion, since we are asked to find the current that is going through this one, and I'm going to tag it with the green color. So the current that is going through this one, to find the current here, we need to find maybe the current that is going through the whole circuit. Then from there, we can try to find the current that is going through this circuit. I think that's the best approach for this one. Okay, so I am going to tag this current that is going through the whole circuit with red color. All right. It doesn't matter where the direction is. I am assuming the direction is here. This is a power source that is non-polar, so you can assume whatever direction you need. So I'm just gonna went with this assumption, going clockwise. All right. So to find the current, this one here, we need to find the equivalent resistor of this whole circuit. Okay. I think, in my opinion, the best thing is just to start by finding the equivalent resistor for this combination, then on parallel with this, then on series with this. All right, let's see. So 15 plus 50, that's 65. So the total resistor here is 65. And this is on parallel with this one. So to find R equivalent for them, so I'm going to put it here, R equivalent, which is, because it's on parallel, I have to say 1 over R equivalent is equal to 1 over 5 plus 1 over 65, and if I find 1 over R equivalent, then take the reciprocal of it. R equivalent will be 4.64 ohm. So this whole circuit resistor reduces to 4.64 ohm. Now this whole circuit, as you can see, it's on series with this one. So to find R equivalent for this one, I am going to write it like this. R equivalent for the whole circuit is basically 10 plus 4.64, and if I do that, I get 14.64 ohm for the equivalent for the whole circuit. Okay, now I have the equivalent resistor, and I have the voltage of the whole circuit. I can find, I'm going to call it I equivalent. And since I tagged it with red, so I'm going to solve that with red just for convenience. So that would be V for the whole circuit divided by R equivalent, and that is 15 divided by 14.64. And if I do this calculation with the calculator, I get 1.02 amps. So this one is 1.02 amps. Perfect. And the same as going through here. It's the same because it goes through this resistor. It doesn't change its value. All right. Now, once it gets here, it's going to split into the green one that goes up here, and I'm going to tag this one with the blue color. Okay. So this is I blue, and this is I green. Okay. Alright, so the red one is going to be a combination of the green one, and the blue one. Now, how do we go about finding the current that goes through this one? We cannot find it before we know the voltage drop across this resistor. And to know that, basically we have to go back here and find the voltage drop across this resistor first, then find the voltage drop across this whole circuit. Then from there, we can find the current here. Let me do this one step at a time, okay? So let's find the voltage drop here first, okay? And I'm going to do it in the white color. So the voltage drop here I'm going to call it V, is going to be equal, V is equal to I times R of the 10 ohm resistor, okay? And the current is 1.02 times the R10, which is 10, and that will be equal to 10.2 volts. All right, so if there was a voltage drop here 10.2 volts and the source is 15, what's left is for the voltage drop here is basically 15 minus 10. So I'm gonna call this green. So the voltage drop here, I'm gonna call it green. Okay, it's the same as the voltage drop here, so don't get confused. The voltage drop, the green one here, will be equal to 15 minus 10.2, and that will be 4.8 volts. So this whole thing is 4.8 volts. Because they are connected on parallel, the voltage drop here will also 4.8 volts, and the voltage drop here is also 4.8 volts, because they are all connected on what? On parallel. Okay, that's great. Now we have the voltage drop and we have the value of the resistor. We can find what? The current. Use Ohm's law again, and I'm going to use the blue one again. So the blue, I'm going to find I, or was it the green? Oh, it was the green, sorry. I'm going to use I, okay, is equal to V over R5, the resistor of 5. So V, we know, we found it is 4.8 volts divided by 5, and that will give me the current for this, the current that goes through this resistor, and it's equal to 0.96 amps. Great. Now we found the current that goes through the 5 ohm resistor. So we solved the first part of the problem. Now the second part is asking us to find the power dissipated in the 15 ohm resistor, which is this one. All right, how do we do that? We know that the power in general is equal to I times V. That's one of the forms. V is equal to IR, so we can use this form. So I squared R. Okay, because V is equal to IR. Multiply I with I square, and R comes down. All right. So we need basically to find the current here, the blue one. And I'm going to write this down in the blue current, I. And I'm going to put the resistor in white. And that's I squared, before I forget. Okay. So I squared. All right, we need to find the current. How do we go about doing that? Well, that's not too hard, because we have the voltage drop across this whole circuit here. All right, and we also have the value of the resistor. So if I take this circuit here and start solving, I can say that the current that goes through here is equal to the voltage drop, which is 4.8, divided by the total resistor, which is 15 plus 50, which is 65. And if you do this calculation, you will find that the current going through this whole resistor combination in series is equal to 0.74 amps. Okay, 0.074 amps. Now, if I want to find the power, then the power is equal to I square, which is 0.074 square, times the resistor 15, because that's what we're concerned with, how much power is dissipated in the 15 ohm resistor. And if we do this calculation, we get the power is equal to 0.082 watts. All right. Some of you may ask a question: is there another way to find the current that is going through this part of the loop? And there is, yes, because we know the main current is 1.02. 0.96 of it go here, as we found out. 0.96 go this way. Then the rest of the 1.02 will go here, which is 0.02 minus 0.96, and that will give you the same answer we got here. So there is sometimes more than one way to solve these problems. I hope this helped. Thank you very much for watching.